So this is Algebra Semester 1. It's the second unit called Inequalities, and it's the sixth lesson called Compound Inequalities. It's on CreatorMathcom under the Algebra 1 tab. You might have to Google CreatorMath.weebly.com to find the site. The instructions are copy the following problems into your composition book on the correct pages according to the table of contents with the notes for those pages from CreatorMath.com. So I'm going to go back and try to model where the notes are, since that can be hard to find for students. So here's the website address, CreatorMath.weebly.com. Type that into Google and hopefully you can find this homepage. Once you're here, this is what it's going to look like, right? If you have any questions about the composition book, please scroll down on the homepage, find the words composition book, and follow all the directions. Watch all the videos, follow the due dates, put everything on the page as they belong. And you should have an 80 to 90 to 100% on your composition book, as long as you've got notes. Let's go to the place where all the notes are. That's under the tab of the class you're in, or the video I'm making right now. So under the tab of the class you're in, or the video I'm making right now, is a list of all of the vocabulary we're going to use for the entire school year. It's a PDF. You can download it to your device, and you can search it. So Google, how do I search a PDF with the type of device you have? It's a little bit different for each device, so follow those directions. We're now going to scroll to the semester of this video, so find the right semester, that's important. And then this is the table of contents that you should have already written on pages 2 through 6 of your composition book. If you haven't done that already, please stop what you're doing now and write it in. Follow all the videos / directions on the home page that we just covered to figure out how to do that. So now we're going to scroll down to the unit. This is the unit here, Inequalities. There are 7 lessons within it. We are on lesson number 6 right here for this video, Compound Inequalities. These are the pages that these notes go on in your comp book. Please don't take this video's word for it, but look up the original table of contents to see the current page numbers by the time you watch this. They probably will be different. Then these are the notes that go there, the problem set we're doing now, and the video solution will be linked here. So we're going to click into Notes to go over that really quickly. Sometimes I have to open this twice to get it to load. This time it loaded fine. You're going to put these notes on the correct pages in your comp book, and this just talks about, in this case, compound inequalities. Here's an expression in the middle between 2 inequalities, and either expressions or numbers, constants on the outside of those. That's why it's called compound, because you have 2 inequality symbols here. So here's how we solve it. Here's an example. Here's a number line and how we graph it, and also we'll probably do set notation on this too. We'll look at as we go through it, because we've been doing set notation through these. There's only a few problems here, but vocabulary that helps you figure out inequality, what equality is in math, what a solid dot means, open dot, what's a greater than, less than, etc., all those things, right? So put those notes in your comp book, and that'll help you solve these problems. So let's just roll down through these. Given this symbol, how is it read? So this symbol's here. We already see it written. This is a greater than symbol. Since this is the 6th lesson in this unit, I'm assuming at this point you know these, all right? So this is less than, right? That's what that symbol means. This is greater than or equal to, right? Greater than or equal to. This one's less than or equal to, so a less than symbol with an equals under it is less than or equal to. And I kind of draw mine with a flat bottom. It's actually probably more like that is the actual symbol if you look at how it's written here. This is an angle symbol when you have a flat or horizontal base to it. But I start to mix them up, and I apologize for that. In general, I'm okay with doing it, but probably if we're nitpicky about it, that's a little bit annoying. So on a number line, what does an open dot mean? That the value is excluded. So say you've got an open dot, and it's on 10. Is the 10 included? No. It has to be a solid dot to be included. An open dot means it's excluded. So we could say this is x is less than 10, right? Less than 10 means 10 is not included. It's less than 10. So, you know, 9.9999999 is included, but not 10. Fair enough? And I'm hoping this is review at this point, so going a little bit fast. So let's talk about a solid dot now. That's an open dot, which excludes the value. A solid dot includes the value. So now you'd say x is less than or equal to 10. Let me get my symbol a little bit better there. The equals includes the 10, so it's 10 and everything below it. So yeah, 9.5, 9, 8, 7, 6, Everything, all the way down to negative numbers, all the way down to negative infinity, right? So now we talk about set notation. What does a parentheses mean? It means the value is excluded. So just like with an open dot, we need a way in set notation to exclude the value. A parentheses is how we do that. If we want to include the value, like with an equals sign, then we're going to use a bracket. So what does this mean? It means the value is included. And we'll do set notation on our answers that follow. So we'll explain that a little bit more. How is this read? This is read positive infinity. And you should know if there's a positive infinity out to the right, what would there be? The opposite of that? Yes, a negative infinity. Negative infinity means off to the left, right? So the number line is, positive numbers to the right, 0 in the middle, negative numbers to the left. If you want to go to positive infinity, you go this way. If you want to go negative infinity, you go that way. Fair enough? It's that way every time, you guys. It's a convention. It's a definition. By definition, that's the way we do it. Is infinity a number? So the answer is no. Infinity is not a number, it's a concept. The concept that numbers either increase or decrease in the form of a negative infinity forever. So if we're going off to the right forever, you can't just say a billion. A billion is not infinity. A billion is a number. Infinity is not a number, it's a concept. You can't say 10 billion. That's just a number on the way to infinity. You can't say a trillion because you're passing by that on up to infinity. Likewise, with negative numbers, they become increasingly large, but negative. So a negative trillion, right, is just on your way to the forever negative values that you can go to, which is never stopping. So it's a concept, right? We understand it in our mind, but we can't necessarily reproduce it at will in our physical realm. A lot of things exist in our mind, but don't exist in the physical realm. For example, a line in geometry, you guys, a line is perfectly flat, infinitely thin, and extends in both directions forever. There's no physical example of that. That does not exist in our physical universe. It exists in your brain, okay, which is amazing. Our minds can conceive things that we cannot see in reality. Okay, solve the following inequality. So here's what we do. If we've got an 11 less than x plus 5, which is less than 14, we're going to subtract 5 in the middle. And now you kind of have two center lines here, one through each of the symbols. What you do in the middle, you must do on both sides of the equation. Okay, you must do out here minus 5 and out here minus 5. What's 11 minus 5? 6. The symbol stays the same, comes straight down. These disappear, so you've got an x in the middle. The symbol comes down, and you have 14 minus 5 is 9. So we have 6, 9. The x is greater than 6 and less than 9. It's in between these. Now we can show this two other ways. Let's use set notation. We're going to use a parentheses to show that the 6 is not included. We're going to use a comma and a 9 and a parentheses to show that it's not included. So this is called set notation. All right, we've done it on the prior notation. We've done it on the prior lessons, so we're going to do it here. Students want to mix this up with a coordinate location, like when graphing, you go out 6 on the x and up on the 9. Nope, totally different. So a point in graphing is totally different topic. Just X that out of your mind. This is a set. The set means it goes from 6 to 9. The 6 is not included, the 9 is not included. Now, how do we show it on a number line? Here's the third representation. Let's put a 0, let's put a 6, and let's put a 9. The 6 is not included because there's no equals, and it's a parenthesis. So we need an open dot on the 6. The 9 is not included, so we need an open dot. And it's every value in between here, an infinite number of values in between those, but not including 6 and not including 9. So we have three different ways of representing this compound inequality. Compound because there's more than one inequality sign. All right, let's do another. So here we have a negative 3 is less than or equal to 1/2 4x plus 6 is less than 5. Did I write that right? I think so. So what I might do in this one is multiply through by 2. No, I don't even need to do that. Let's just go ahead and distribute here. Fortunately, they gave us a 4 and a 2. So 4 divided by 2 is 2x. And 6 divided by 2 is plus 3. There we go. I like that way a little bit better. If the fraction were a little bit gnarly, we would do a different direction. But let's stick with this for now. So now we're going to go ahead and subtract 3 from the sides. In this case, there's 3 columns to subtract from. Minus 3. right? So okay, so let's see here. This becomes, let's see, -3, so -6. -3, wait. -3, good. Okay, -3 is -6, less than or equal to, sorry I'm being distracted here, is 2x, is less than 5 minus 3 is 2. Okay, now we're going to divide through. We're going to divide this by 2, this by 2, and this by 2. Come over here. We're going to get a -6 divided by 2 is -3, is less than or equal to 2 over 2 is an x, and less than 2 over 2 is a 1. So we have x is greater than or equal to -3, and x is less than 1. It's sandwiched between these two values. Now I'm going to circle this one, and I'm going to make sure to correct this to -3, because I don't like that. That's what my brain was looking at as we were doing this. I'm like, I don't like that answer at all. All right, so I'll work on that. Now, if we represent this one this way, let's do it in set notation. The -3 is included, so we need a bracket. So -3 and comma, where the 1 is not included because there's no equals, so parentheses. This is set notation. Bracket, -3, 1. Let's do it on a number line. We have a 0, a 1, and a -3. So the -3 is included, so we need a solid dot. The 1 is not included, there's no equals to it, so it's an open dot. And then it's every value in between here, all right? An infinite number of values. That's what it looks like on a number line. Okay, let's go for this one. 0 is less than -2x minus 4 is greater than or equal to -6. That's what we've got here. Did I write it right? So let's add 4 to all sides. Gone from the middle, -2x in the middle, less than, we have a 4 here. We have a greater than or equal to here. And -6 plus 4 is -2. We can now go back and divide everything by -2. Now the rule is, in dividing by negatives or multiplying by negatives, we have to flip the signs. So these signs are actually going to flip this way and this way. Right? These disappear. We have x, and we have 4 divided by -2 is -2. And we have -2 over -2 is 1. So we have -2 is less than x, which is less than or equal to 1 right here. Now let's represent it in set notation. The 2 is not included, so we need, or the -2 is not included, so we need a parentheses, comma. The 1 is included because there's an equals here, so we need a bracket around it. That would be our set notation. On a number line, we have a -2 and 1. Let's do 0, 1, and a -2. Right? So the 2 is not included, so we need an open dot. The 1 is included because it's equals to, so we need a solid dot. And it's every value between this, an infinite number of values between 2 points. Right? So make sure you're matching up the title of this video, which is, for this case, is Algebra 1, Semester 1. It's the unit on inequalities, and it's the 6th lesson on compound inequalities, and it's on CreatorMathcom under the Algebra 1 tab. Hope that helps.